right, today we're just going to do a quick refresher on perimeter and area of figures. If I look at number one gives me this rectangle ABCD, and we want to find the perimeter and the area. So just so you remember what the perimeter is when I find the distance around a shape. So if I was to travel around this rectangle, how far would I have traveled? So essentially what I need to do is that I need to figure out the length of each side. So I can do this simply by counting. I could say this is 1, 2, 3, 4. This is 4 units long. This is 2 units long. Rectangle has opposite sides are the same, so this will be 4 and this will be 2. So my perimeter, so I'm going to say P equals 2 plus 4 plus 2 plus 4. Or you could have said 2 times 2 because there was 2 of them, plus 2 times 4 because there was 2 of them. Either way, you would get the same answer of 12. Okay? So since we're talking about perimeter here, the perimeter is simply just going to be units, because we're finding that distance around. So this is 12 units long. Okay, so now let's talk about the area of this rectangle. So hopefully you remember how to calculate area. So area of a rectangle so this formula goes for rectangles, squares, parallelograms. It's just area equals base times height. So if you remember the base of a triangle or a rectangle or a square, so the base of any figure is always perpendicular to its height. So remember, that means that it forms right angles. So if I look on this diagram here, I know that I have 4 right angles because this is a rectangle. So you essentially can use any side to represent your base and your height. So I'm going to say that this side DC is my base. So my height would have to connect to it with a right angle. So I can either use DA or I could use CB, but I'm just going to use DA here as 2. So area equals base times height. So area equals 4 times 2. So the area would be 8. And in this case, we're talking about area. So it's that amount of space that this figure occupies. So that's going to be units squared. So the perimeter, you just essentially add up all the sides. It's the distance around the figure. The area, in this case, it was a rectangle, so it would be the base times the height. You just have to remember that the base and the height connect to form right angles. So if I look at number 2, this is essentially a right triangle, so we can add in our right angle right away. So I am going to start off with the perimeter. So my perimeter, well, how long is the side AB? 1, 2, 3, 4 units long. How about BC? 1, 2, 3 units long. Well, I have a problem. I don't know AC. So I'm going to put X. If you remember from before, we had a way to figure out what that hypotenuse, what that unknown side was. And it was the Pythagorean theorem. So we could say x squared equals 3 squared plus 4 squared. So this would be x squared equals 3 squared is 9, 4 squared is 16. So I can add those two together to get 25. So remember, at this point, we need to take the square root of 25. So I can say second x squared, 25. So my hypotenuse here is 5. So I need all three sides in order to figure out the perimeter. So now that I know them, I can add 3 plus 4 plus 5. Well, 3 plus 4 plus 5, that would give me a perimeter of 12. Is the perimeter always 12? Nope, it just happened to be the case for example 1 and example 2. All right, let's talk about the area of a triangle. That formula is a little bit different than a rectangle. So if you remember the area of a triangle, the shape of a triangle is 1/2 of the rectangle. So the area equals 1/2 the area of a rectangle, which is base times height. So the area formula for any triangle is going to be 1/2 base times height. Again, the base and the height have to form a right angle. So in this triangle, I couldn't just pick any two sides. I need the two sides that form the right angle. So I'm going to say that this side BC is my base, and it connects to AB, which I'm going to call my height. So area equals 1/2 3 times 4. So remember, there's a few different ways you could put this in your calculator. You could put 0.5 times 3 times 4. You could do 3 times 4 and then divide that number by 2. So however you want to do this in the calculator, so I'm going to say 0.5 times 3 times 4. So I would get my final answer is 6. And then since this is area, it's units squared. 6 square units is that area of the triangle. Okay? So if you look at number 3, it just wants us to find the area. So it doesn't want us to calculate the perimeter anymore. So if I look at the area of this figure, let's add on some letters here. I'm just going to say this is A, this is B, and this is C. Well, we need to find the area. So I'm going to write down the formula. So it's 1/2 base times height. Do you see any right angles here? Well, unfortunately, no. So we're going to have to actually draw in the height for ourselves here, okay? So I'm going to use AC as the base because I can easily count this base. So if I count, this is 1, 2, 3, 4, 5 units long. So I can now draw in the height from the opposite ordered pair here, because remember, the opposite point, meaning point B, because the base and the height have to form a right angle. So I can say, okay, if I drop down this line, wouldn't it be perpendicular to the base? So how many units is that? So we can say this is 1, 2, 3, 4, 5. So I know that this height is 5. So my area equals 1/2 times 5 times 5. So we can put that in our calculators. And we should get 12.5 units squared. If I look at the last one, it's like this obtuse triangle. So I don't have any right angles at all. So I'm going to have to, again, worry about the base and the height. So if I look at which one is the easiest to count for the base, well, it's this vertical side. The other two sides of this triangle, This obtuse triangle are slanted, so those are not easy to calculate. But if I look here, this would be 1, 2, 3 units long. So in an obtuse triangle, the height is usually outside the triangle. So meaning the point across from that base is A. So if I needed to drop down a height, drop down a perpendicular line to that base, I'm going to just have to drop it down outside the triangle. So we need to figure out what is the height of the triangle. So essentially it would just be this distance here. So it looks like 1, 2, 3 units long. So if you ever have a triangle that looks like this, it's possible for the height to be outside the triangle. So that height that corresponds to that base is going to be 3 units long. So I'm going to say area equals 1/2 3 times 3. So if I think about this, 3 times 3 is 9, and then half of that would be 4.5 units squared. Okay, so remember when you're doing this, you have to pay attention to a few things. If you're talking about perimeter, do you have all the sides? If not, you might have to use something like the Pythagorean theorem to calculate the missing side in order to find all sides. Area, the most important part to remember is that the base and the height form a right angle. So if the right angle is not given to us, we might have to, like in number 3, drop down the height, which was inside the triangle because that was an acute triangle. Or number 4, we're going to have to drop down the height outside the triangle because that's an obtuse triangle. Okay, this was a quick review of area and perimeter of rectangles, triangles, etc.